this tutorial, we're going to learn about the three types of solutions you can have when solving equations with single variables. So if you have your packet, you can follow along. If you don't, you can write these examples in your notes. So there are three types of solutions that can occur after you finish simplifying your entire algebraic equation. So don't forget, when you're simplifying an equation, you always follow the same steps of distributing to clear parentheses, combining like terms to shorten one side, using an inverse operation like addition or subtraction to move pieces from one side to the other, and the last step is to multiply or divide to separate coefficients from their variables. So let's take a look at our first example here. One solution. What does it mean if your equation has one solution? Well, let's start simplifying this equation. You can follow along by writing in your packet or copying this down in your notes. So 3 times 2x is 6x, 3 times 9 is 27. Negative 5 minus 2x, there's nothing to do on the right hand side. So from here I check to see if I can combine. So I see that I have an x over here, but my other x is all the way over there. And if you have to pass the equal sign, then you're not combining. You cannot combine terms that are not on the same side. So if I want this negative 2x here to come over and combine with 6x, I need to switch its sign. Right? I need to use an inverse operation here. I need to use an inverse operation to switch that sign. So positive 2x on both sides. And then I rewrite my question. So here I can combine. Here I rewrite. Equal sign is a rewrite. Minus 5 is a rewrite. And this is a cancellation. Now my last step is to get my constants together. You never want to empty a whole side like this. You never want to empty a whole side. So never do that. So this is the longer side, so these are the pieces I need to do the inverse of. But since this has a variable and the other side doesn't, I cannot use the variable term. So I'm going to subtract 27 from both sides, cancel out my inverses, rewrite what's left. And now I'm ready to divide both sides by my coefficient, and I get my final answer, which is negative 4. So that's what one solution means. This one number is the only number that I can plug in for that letter x that would make both sides of these equations true, right? Where the left side is equal to the right side. So you can certainly do a check step here by plugging that negative 4 into the letter x. And if you're not sure what I mean by that, let me show you how you start a check step. You rewrite the entire equation, but you remove the variable. So notice I'm writing 3 parentheses 2, and instead of an x, I'm putting more parentheses. And on the right hand side, I'm going to do the same thing. I'm going to remove those parentheses, but in here, instead of the letter x, I'm going to put my actual answer, which is negative 4. And then I start using my order of operations here. Multiply before adding, right? 2 times negative 4 would be negative 8. Negative 8 plus 9. So that's what I'm going to get on the left-hand side. 3 times negative 8 plus 9 is 3 times 1, which is 3. Now let's see if it's actually equal to the right-hand side. So negative 5 stays, but negative 2 times negative 4 becomes a positive 8. This simplifies to positive 3. If I bring it down to the next line the same, then that is a check step. Alright, let's take a look at our two special cases now. The two special cases are no solution and infinite solutions, right? No solution and infinite solutions. Let's take a look at what the difference is here. So I'm going to combine terms here because they're on the same side. Over here I'm going to distribute 4x plus 12 plus 1. And now I have like terms over here. So when I rewrite, I get 4x minus 9 equals 4x plus 13. And now I have to get my x's together. So they're on different sides of the equal sign, so I need an inverse here. I need an inverse operation. It doesn't matter which one I start with. But what happens when I do that is I actually get a double cancellation. Both x's cancel out. I never want to see you do this. Never want to see you do that. Alright? If you have no x's left, you should not be writing the letter x at all. You have no x's left. Right? So when I rewrite my problem here, these are gone and these are gone, but the -9 and the 13 still remain. And if your statement is not a true statement, see, -9 is definitely not equal to 13, then after you put that slash through the equal sign, you must interpret this answer. You must interpret this false statement as saying, there is no value of x that when plugged in would be equal on both sides. So the answer is no solution. You can write it in English like this, or if you'd like to be fancy, you can write this mathematical symbol for nothing, which is different than the number 0, right? Nothing is different than 0. 0 is a number. 0 could work. But if nothing, not even 0 works, you could write this symbol for the empty set. So that's an example of a question that comes out as no solution. Now let's look at the infinite solution example. So if I distribute here, I'm going to get -6x plus 10. And if I combine over here, I'm going to get -6x plus 10. Wow, I'm noticing something already. I'm not sure if you picked up on that. Left side says -6x plus 10. The right side says -6x plus 10. But let's continue by using an inverse operation and see what happens. Now, anytime you get a double cancellation, you've got a special case on your hands. So if the letter cancels out on both sides, and what remains is equal, then that's an example of infinite solutions. Infinite solutions. So you must write this English phrase. You can't just leave this statement here and expect the reader to interpret it. You have to interpret that if the left side is actually indeed equal to the right side, that you have a case of infinite solutions. And if you're feeling fancy, you can use the mathematical symbol for infinite. Infinity here is kind of like a sideways 8. That is the symbol for infinite solutions. Alright, at the bottom of your worksheet here, we're going to take a look at these 4 examples that are coming up. I'm going to do 2, and then I'm going to ask you to do 2, and then we're going to check your work. I think I'm going to do number 1 and 4. If you think you know what you're doing, you can certainly pause the video now and give it a try on your own. Otherwise, get your pens or pencils ready, and let's follow along. Nothing to do on the left. Distributing to do on the right. Combining to do on the right. Nothing to do on the left. 6 x's, take away 1 x's is 5 x's. Now I'm noticing it already, but I'm not sure if you do. But when your left side and your right side match exactly, that's infinite solutions. But let's go ahead and prove it by canceling out these variables and showing the actual true statement, right? If -3 is equal to -3, then you must write infinite solutions. You can write it in English, infinite solutions, or you can write it in math with your new fancy infinity symbol here, but you can't just stop at this statement. You must interpret it here. Alright, I'm going to try number 4 now. Got some distributing to do. 8k minus 12 plus 1 is equal to 8k minus 11. Got some combining to do here. 8k minus 11 equals 8k minus 11. Oh, you see that? Anytime the left and the right are equal, you can stop right now and you can answer that it's infinite solutions. But if you want to prove it, you can certainly subtract your variable from both sides here and prove with your cancellations that -11 is indeed equal to -11. Alright, once you give 2 and 3 a try on your own, pause the video and unpause the video when you're finished. Okay, let's take a look at the solutions now that you've had some time to try numbers 2 and 3 on your own. The answer to number 3, or 2, the answer to number 2 is negative 6. And the answer to number 3 is no solutions. Again, you can write it in English, no solutions, or you can use the mathematical symbol, which is the empty set, right? The circle with the line through it. All right, let's turn the worksheet over and try some on the back. So I'm going to answer number 6, and then I'm going to ask you to try numbers 5, 7, and 8 on your own. So we need to distribute here, but the 3 is not touching the parentheses. So the 3 is not going to be used, but this minus invisible 1 is going to be multiplied. That gives me a minus 4w. That gives me a minus 5. And now I got to multiply this fraction. Looks scary, but half of 8 is not that hard. Half of 8w is 4w's. And half of 28 is 14. Now I look to see if any of my sides are too long. And I see here that this side is too long. It has 3 terms. So I'm going to combine my like terms together here. 3 minus 5. That says 3, take away 5. So that gives me a negative 2. Let's see, I always like to move my letters first, because if they're going to disappear on me, I want to know right away. So it looks like I'm going to do the opposite here. And they might have the same numbers, but only this one actually cancels out. So I've got negative 2 equals 8w plus 14. Subtract 14, subtract 14. Negative 16 equals 8w. Divide both sides by the coefficient. And I get my final answer. Now if I want to know if I'm right, I'm going to plug this number 2, negative 2 in for w, and I'm going to check to see if these two sides are equal. Alright, take a moment to pause the video and give these next 3 a chance on your own. Okay, now that you've had a chance to give these 3 a try, let's take a look at your solutions. So number 5, c is equal to negative 8. Number 7, there are no solutions. You can write it in English, or you can use the mathematical symbol for empty set. And the answer for number 8 was m is equal to 6. So pause the video here, check over this work, and see how you did. Alright, let's give these last 4 a try. So we have 9, 10, 11, and 12. I think I'll try number 12 for you. Okay, so number 12, let me scroll up to give myself some room here. I got to distribute here, but remember, this 7v is not touching the parentheses. This minus sign is, so I'm going to fill in that invisible 1 again. 7v, distribute this negative 1, distribute it again, and watch your signs. Negative 1 times a minus 16 is a positive 16. Distribute on the right, distribute all the way. Look for a side that's longer than 2 terms. That's here. Combine if you can. 7v's take away 2v's, or 5v's. Over here I got 5v plus 20. Now I'm noticing something right now. Got 5v's on both sides, so those match, but my constants don't match. So let me clear off this 5v just to prove that this could never be true, because 16 is never equal to 20. So you have to put that slash, and you have to interpret it. So you can either write it in English, that there are no solutions, or you can write your empty set symbol. Doesn't matter to me, but you must write one of these. Alright, take a minute to pause the video. Give these last 3 questions a try, and then I'll show you the solutions. Okay, now that you've had a chance to try them on your own, here are the last 3 solutions. Take a moment to pause the video, check your work, and make sure you actually interpreted your solution as infinite solutions using the infinity sign, or no solutions using the empty set symbol. And that concludes the video on 3 types of solutions when solving equations.